All right. So you ever wonder how SpaceX keeps pulling off these feats, these engineering feats? I mean, things that seem like they're straight out of science fiction, right?
Hmm.
That's what we're looking at today. We're doing a deep dive into how SpaceX innovates. And trust me, you don't need a rocket science degree for this. Like, you can apply these secrets to your own work.
Yeah.
It's really fascinating stuff. So we've got two awesome articles we're diving into today. Both of them offer a behind-the-scenes look at how SpaceX recovers those rocket fairings.
Okay.
You know, those nose cones that protect the payloads during
Right.
launch.
Right. Yeah.
So, I mean, it's expensive equipment, right?
Oh, yeah. Hugely so.
Yeah.
So it's always been one of the big challenges in rocketry is how do you recover those pieces? Because they're so expensive to make. And for so long, it was just like, well, it's gone.
It's gone, yeah.
That's part of the cost.
It's the cost of doing business, right?
Yeah.
SpaceX is like, I don't think so.
Yeah.
So, picture this. You just launch a rocket into space. Now, you got to recover that nose cone, that fairing. Seems pretty simple, right?
Mm-hmm.
Just pluck it out of the sky. Well, easier said than done, right? That's what everybody thought. But there's a catch, literally.
Right.
So early attempts, this is great. This is like Wile E. Coyote stuff. They were using boats with these giant nets, trying to snag these fairings as they're plummeting back to Earth.
Yeah.
So, I mean, can you imagine?
It's a big old thing to catch.
It's a big old thing, and it's falling from space.
Yeah. I mean, it's not going slow.
No, it's not going slow. So, and the prevailing assumption was, well, salt water is going to ruin these fairings like they're toast.
Yeah, you got to figure salt water and electronics don't mix.
Mm-hmm.
Salt water and anything delicate probably don't mix.
Right, exactly.
Yeah.
But that's where things get really interesting because SpaceX, they challenged that seawater is the enemy kind of belief.
Right.
And that's when things really start to change. And it's a powerful lesson, I think, in any field, really. How often do we let these ingrained assumptions, not even like actual data, but these assumptions dictate how we approach problems?
Yeah. It's like we kind of get locked into these mental models
Right.
of how things have to be.
Exactly,
Yeah.
because that's the way they've always been done, or at least that's what we've always thought.
Right. Yeah.
But they could have easily just said, well, this is how it's done, and stuck with this whole boats and nets thing, right?
Yeah.
But instead, they thought, what if we could turn these fairings into giant steerable parachutes?
Oh, wow.
Right. Cue the parafoils. And even getting to that stage, turning these massive structures into something that could descend gracefully from space, that was a huge engineering accomplishment.
Oh, absolutely.
Yeah.
Right.
Yeah.
I mean, just that alone.
Yes, getting it down.
Just getting it down, that's huge.
Yeah.
But the takeaway here isn't just the parafoils themselves.
Right.
It's SpaceX's mindset of how do we make this even better? We're not going to stop.
Keep pushing it.
We're going to keep pushing, keep iterating. And that led them to develop, and this is what we're calling it at least, we're calling it the SpaceX algorithm.
It's a 5-step process for unlocking innovation.
Okay.
I love this part. And the best part, this isn't just for rocket scientists, okay? This is an algorithm that can be applied to anything from designing a website to just streamlining your daily to-do list. So we're going to break this down step by step so you can start thinking like a SpaceX engineer.
Okay.
All right?
I like it.
So it all starts with a very deceptively simple phrase, and it's this: make the requirements less dumb.
Okay.
I know that sounds a little cheeky.
Right.
But let's go back to the fairing example. So the initial requirement was it has to avoid water at all costs.
Right.
But when they stopped and asked why does it have to avoid water entirely? That's when things started to open up.
Yeah. That's when the possibilities open up.
Yeah.
When you eliminate this arbitrary requirement.
Exactly. Yeah.
And that is the beauty of this first step.
Yeah.
Sometimes the most innovative solutions come from questioning the very foundation of the problem.
Right.
You know, it's like instead of just accepting the way things are, you ask why.
Yeah. Why? Why is that a requirement?
Exactly.
Yeah, exactly.
Challenge the status quo.
Mm-hmm.
Yeah.
So it's like you're stuck with this recipe
Right.
and you can't deviate from the recipe. And
Yeah, yeah.
somebody finally says, well, why does it have to be that way?
Yeah, yeah. What if we add a little spice to this thing?
Exactly. Exactly.
That's
So,
when things get interesting.
yeah, you might find something amazing, right?
Yeah. That shift in perspective, that's what SpaceX used to tackle this whole fairing thing.
Yeah.
So, step 2 in the algorithm. Delete the part or process step.
So for the fairings, that meant ditching that whole midair catch,
Right.
which easier said than done.
Right.
But what about your work? I mean, think about that for a second. What's your midair cache? Like, what's that one step in your process that just seems essential, but it might be making things way more complicated than it needs to be?
Yeah. It's so easy to fall into that way of thinking.
Right. That's how we've always done it.
Yeah, we've always done it this way, therefore it's the right way.
Right.
But sometimes the most elegant, simplest solution is the best.
It is. It is.
And you see that, think about the evolution of cell phones, right?
Oh, yeah.
You go from these big, clunky things
bricks.
with all these features
Yeah.
that you don't even use. And now it's like we've got these sleek, powerful smartphones.
Yeah.
And it's because they stripped away all the non-essentials
Yeah,
focused on the core.
It's that 80-20 rule, right?
Yeah. Exactly.
And that's what SpaceX realized with these fairings, right? Instead of trying to catch them in midair, which was difficult and expensive, they were like, okay, what if we let them splash down in the ocean?
Okay.
Gently, using parachutes, right?
Okay.
Slow them down a little bit,
Mm-hmm.
and then just go fish them out.
Right.
It seemed counterintuitive at first because everybody was like, seawater's the enemy. But they had already challenged that assumption.
Right.
So that's the thing.
They took it apart.
Yes.
Right. They said, well, why can't it touch water?
Yeah.
Okay. Maybe it can. What do we have to do to change our process if we let that happen?
Exactly. It's like they cleared away all that clutter.
Right.
To make room for a better solution.
Yeah.
And the results speak for themselves. Because of this, their fairing recovery rate went from under 50% to 99%.
That's amazing.
It's huge.
Yeah.
It just shows you what happens when you just streamline things.
Yeah. Just question those assumptions that we make, and we all make them.
We do.
Yeah.
So, but wait, there's more.
Okay.
The algorithm, it doesn't stop there.
Okay.
So once you've made those requirements, less dumb,
right,
and you've deleted the unnecessary steps, now it's time to optimize, accelerate, and automate.
Okay.
So those are like the final 3 steps.
Yeah.
And it's all about taking that simplified core
Yeah.
and making it as efficient as possible.
Okay.
Right?
Right.
It's that constant improvement.
Right.
It's looking for ways to just shave off seconds here and there.
Yeah. Just that constant iteration.
Yes.
Yeah. Make it smoother,
Yes.
more reliable.
Exactly. It's like you've decluttered your workspace, right? You've streamlined your workflow. Everything's nice and neat.
Yeah.
But now it's time to fine-tune it.
Yeah.
Make those steps sing.
Exactly. Exactly. And that's what SpaceX did, right?
Yeah.
They didn't just say, okay, we'll fish him out of the ocean. That's good enough.
Right.
They kept iterating. They experimented with different recovery vessels. They were tweaking the design of the fairings, even analyzing weather patterns to figure out, okay, when's the best time to go get these things?
To optimize that.
Yeah, to optimize the retrieval time, minimize the amount of time they're exposed to the elements, all that,
Because that constant push for improvement, right?
Yes.
Never being satisfied.
Never satisfied. And I think that's a big part of their secret sauce. It's that they're never satisfied.
Yeah. They're not afraid to break things either, I guess, to a certain extent.
Well, yeah. I mean, they expect to have failures.
Right. Yeah.
But that's how they learn.
That's how they learn. Exactly.
Yeah.
It's all part of the process. So, I mean, what does this all mean, like, for the average person? Let's bring it back down to earth for a second. So you're working on a project. It's way too complex, right? It's just, this is so much.
Right.
Ask yourself, what are the must-haves here?
Yeah.
And are they actually must-haves, or is it just, this is how we've always done it?
Exactly. It's questioning those assumptions.
Yeah.
Why is that a requirement?
Yeah, exactly. And that's that step 1, right?
Right.
Making it less dumb.
Make it less dumb.
And then what can you just get rid of?
Right. What can you eliminate?
What's just there? What's adding complexity and not really adding any value?
Right. Is there a step in your process you can just delete?
Yes.
Right. Does it need to be there?
Exactly.
What can you streamline?
And then once you've stripped it down,
right.
Once you've got it down to the essentials, now it's time to optimize, accelerate.
Yeah, this is where you get to fine tune it.
Yes.
Right. Make it really sing.
Yes. I love it.
So, what can you do to make things smoother, faster, more efficient? Can you use better communication? Can you leverage technology to automate some of those tasks?
Well, yeah.
Right? There's all sorts of things you can do once you've got that core down.
It's amazing to me how much hidden potential we miss because we're just so used to doing things a certain way.
Right. because we're afraid to change.
Yeah, it's that fear.
Yeah, exactly. Or we're just stuck in our ways.
Right.
This is how we've always done it. It's worked so far.
Why change? Right?
Right. Why change now?
If it ain't broke, don't fix it.
Right, exactly. But sometimes you can make it even better.
You can.
If you're willing to question those assumptions, those ways that you've always done things.
Absolutely.
Yeah.
So, if rocket science can be simplified,
Right.
I mean, think about that. If rocket science can be simplified,
Yeah.
imagine what we can achieve when we start applying that same mindset to our everyday work, our everyday challenge, whatever it is.
Exactly. Exactly. Doesn't matter what field you're in.
Yeah.
These same principles apply.
I love it. So next time you're facing a challenge,
Mm-hmm.
something that seems impossible,
Right.
remember the SpaceX story, remember the fairings,
Right.
and remember even the most complex problems.
Yeah.
You can solve them.
Yeah.
It just takes a little ingenuity, a willingness to challenge the way things have always been done.
Yep. That's it.
And a healthy dose of, let's make things less dumb.
Make things less dumb. I love it.
All right, that's it for this deep dive. Hope you enjoyed it. We'll see you next time.